right, in this video, we'll review the tape measure, protractor, and dimensions tools. Fundamental tools that are essential for precision layout and accelerating modeling workflow. We'll review how they not only measure distance and angles, but also how we use them to establish guide points and guides for rapid layout, and finally how to scale individual entities or the entire model with ease. Let's dive in. All right, first, the tools do what you'd think they do. The tape measure measures the distance between 2 points, and the protractor measures angles. Consider this arbitrary quadrilateral. I can use the tape measure tool to measure the distance of any of these edges. Click on one point, pull over, click on the other point, and there you see. So for example, edge A is 36 9/16, edge B is 76 1/4, and so on. I can also measure each of these angles using the protractor tool. Click on the vertex of the angle, click on one of the edges defining that angle, rotate over and click on the other edge, and there you go. So for example, the angle defined by AB is 109.4 degrees. The angle defined by BC is 79.5, and so on. Now you also notice these hashed lines that were just created by the protractor tool. Hold that thought, we're going to come back to that. Now I can also annotate the model with those dimensions using the dimensions tool. It works similar to the tape measure tool, where I click on one point of an edge, pull over, click on the other point of an edge, and then if I pull out parallel to that edge and click, I can display the dimensions of that edge directly on the model. So again, edge A here, 36 9/16, edge B here, 76 1/4, edge C, 35 5/64, and edge D, 82 inches. Now here's a pro tip. I like to change the format of the dimensions to something that's more readable, and I can do that in two ways. First of all, I can go into the entity info for any of those dimensions and change its font, its typeface, style, and size directly. The faster way though, the way that I prefer, is instead to go into the model info. And so if I go into the model info, I can set the default of the format of my dimensions. So in my case, I like Montserrat, so I'll go ahead and select that. I'll go with extra bold as the style, and I'll bump up the size to 24. Now that'll be the default for any dimensions I create from that point forward. Now what's handy here is I can also select all of the dimensions currently in the model with this handy button here, and then apply any changes I've made to all of those selected dimensions. So maybe one other thing I want to do here is change the endpoint style from the closed arrow to the slash. I'll go ahead and update all of the selected dimensions with that sort of format. And there you go. That's something that in my opinion is much more readable and the way I prefer to annotate my models with the dimensions. All right, now that's all great, but perhaps what I really need is the overall height and length of the quadrilateral along with the offsets of where those points start. That can be most useful when it comes to laying this out on sheet material to make sure it fits, and also to accurately lay out where my cuts are. Now there's a number of different ways to do this, but in my opinion, the cleanest way is to use the tape measure to establish guide points. So let me just go ahead and clean out those dimensions I just created, and then we'll start to establish our guide points. Again, using the tape measure, click on one endpoint of this, in this case of the quadrilateral, and then begin moving over, and then you'll notice that SketchUp is trying to guess what I want to do. See at the midpoint there of the quadrilateral, it's hard to see, but there's a faint green dashed line. That's SketchUp's inference engine, again, guessing what it is that I want to do. Super powerful, and we'll get into that in other tutorials. But what I actually want is the point over here. That's the one where it's snapped to that defines that endpoint of the quadrilateral in that upper corner. So I'll go ahead and click there, and that cross mark that you see is a guide point. It's a handy reference point in 3D space. I'll do the same thing for this upper corner over here, so I'll click on the endpoint here, pull over, it's snapping again, guessing what I want, and it's established another guide point there. You'll also notice this dashed line here in the upper corner. Well, it's actually in the bottom one too. It's just sort of hidden by the red axis, but if I go ahead and turn the axes off, you'll see that those guide points have associated with them those dashed lines, and it's just an indicator of where that sort of originated from. All right, now that I have those guide points, I can use those to directly establish dimensions. I'll go ahead and click on the dimensions tool, and I'll start here from this bottom corner and then go ahead and pull up and click on that guide point that I just created. And that's now giving me the height of the quadrilateral. I'll do the same here and work my way around. So I'll start at this guide point here, click here on the end point, and that's telling me the offset of where that top end point starts for that edge B. I'll go ahead and work my array around further. And this should be the same as 4. That's the length of edge B, which is 76.25. And I'll go ahead and do the height over here as well. And in this case, because edges B and D are parallel, that height is the same. But if they weren't, it'd be helpful, obviously, to have the different heights there. So I'll go ahead and put that as well. And then I'll go ahead and add this offset here. And then finally, this one here, which again will be the same as before. It's the length of that edge. I'll also do the entire length. So I have the height already, but I'll start at the beginning and work to this endpoint guide that I created. And as you would expect, it's 88 3/8, which jives with the 82 plus the 6 3/8 we see at the bottom, and the 12 1/8 and 76.25 we see at the top. Now this is more helpful as it gives me everything I need to lay this out and cut it without having to deal with the odd angles. I can just literally measure and cut. Simple enough. But that said, it still might be useful to annotate the model with those angular dimensions. Now the only downside, for whatever reason, SketchUp didn't build in a way to display angular dimensions directly in the model the same way you can do it with linear dimensions. But the good news is there's a simple extension you can get from the Sketchucation community called, shocker, angular dimensions. Now it works a little bit different than the Protractor in that you first click on an edge, then the vertex, then the opposing edge that defines the angle that you want, and there you go. It'll generate a display of that angle right on the model. So in this case, angle AB is 109.4, and I can work my way around from there. Now, one thing to note here is that the first and second pick points will define the radius of the angular dimension that's displayed. In other words, the farther away you pick from the vertex, the larger the angular dimension display will be. And that'll be helpful in terms of readability and how you want to lay out your dimensions and things like that. Well, there you have it. I have a fully annotated model that has the length of each edge on it. It has the offsets that help determine that arbitrary quadrilateral. It has the overall height and width of that. That's useful for layout purposes, along with the angular dimensions as well. Super helpful. Now here's a pro tip, and I'll talk much more about this in another tutorial, but I like to use tags to keep things organized. My model's already starting to get a little bit cluttered here. So in this case, I like to tag all my dimensions so I can quickly show or hide those as needed. Now in prior versions of SketchUp, they called this layers, but tags actually makes more sense in the way it's used. Basically, you can select any entity and then tag it, and then you can turn on and off the display of entities by tag. So let's go ahead and create ourselves a dimension tag. Go ahead and here into the tags dialog, and I'll create a new tag called dimension. And then I can individually select anything I want and tag it with that, or I'll go back into the model info and use that handy shortcut feature to select all of the dimensions in my model, and I'll update them all at once and tag all of them with that dimension tag. Now that I've got those tagged, I can use this icon right here and click on that to turn off and on anything that is tagged with dimension. Super handy. Now I could do the same for the angular dimensions, or if I want to be more granular, I can actually create another tag. So in this case, I'll create a new one called angular dimension. And I'll go ahead and select all of my angular dimensions in the model. And then back over here in the entity info for those entities, again, I can select that right here. I'll go ahead and tag those with angular dimension. And now I have pretty granular control over displaying and hiding exactly what I want on the model. Again, super handy. All right, again, I'll go into more depth on each of these capabilities in other tutorials, but that's a very simple set of examples of how you can use the tape measure, protractor, and dimension tools to quickly and accurately identify useful dimensions of the entities in your model. Now I find annotating the model this way incredibly useful. I'll print it out, go into the shop, and I can immediately begin cutting. All right, now that we understand the basics, let's dive into guides, possibly the single function I use most in SketchUp. Now consider this geometric feature element. Technically it's referred to as a frustum. It's a fancy geeky name that actually be relevant when we dive into the in-depth tutorials. Now while this can be modeled in a number of different ways, I've come to really like modeling objects like these as extrusions of a profile, and we'll learn how to do that using the Follow Me tool in the in-depth tutorial for this. But for now, let's focus first on modeling just that profile. Now, a few knowns. It's roughly 14 inches tall, and this side or spring angle, a clue for all you trim carpenters out there, is 31.6 degrees. I know, it's super random, and I'll get into the why and all the gory detail behind that in the in-depth tutorial. But for now, trust me, follow my lead. And finally, we want this element to be 1 inch thick. Now that gives us everything that we need to begin modeling, so let's go ahead and jump into SketchUp. All right, so here we are in SketchUp, and like always, I'm in a woodworking template, and I'll start at the origin. First, I'm gonna make things easy at myself and look at this from the right side of the model by clicking on this camera view here. This will make it easier for me for this first series of modeling operations. Now, it's good to get familiar with these camera views as a quick way to look at your model from different perspectives. Now, given my first known of 14 inches tall, I'm going to draw a few guides to establish a 14 by 14 bounding box as a helpful way to model the profile. And we use the tape measure tool to draw a guide by first clicking anywhere on a linear element in our model. So in this case, I'll use the vertical axis, then pull out from that vertical axis. And then you can either pull to the distance you want, or like other operations we've discussed, you can simply type in the exact distance for the pull. Now, for this first guide, it's not really important to be specific, so I'll just establish it at an arbitrary distance from the vertical axis. But for the second one, I want it exactly 14 inches from the first one, so I'll type that in. Now, I just want to point something out I just demonstrated that's easy to take for granted, but is super useful. You can use one guide as a reference or starting point for another guide. Again, I've found using guides and this method super helpful to really accelerate layout as an alternative to trying to draw or model directly. Now, I'll do the same for the top and bottom. And now I have myself this 14 by 14 bounding box that'll help constrain the rest of my modeling for this profile to stay within that boundary. All right, next I'll go ahead and use the Protractor tool to draw myself a useful guide at 31.6 degrees, my desired spring angle. Now here's a good example of where it's really helpful to enter dimensions directly. The Protractor will snap to common angles like 15, 30, 45, and so on, but it's not nearly as easy to hit something as arbitrary as 31.6. So entering that directly is the way to go. All right, next I know I want my piece 1 inch thick, so I'll use the tape measure tool to reference off that angular guide I just created and the bottom guide to create guides at an offset that represents a 1 inch thick profile. Now it's as simple as basically tracing over those guides using the pencil tool. Notice how I now have a closed face representing that profile. That's perfect. Now I'll go ahead and finish this off by annotating it with the dimensions like we did before on the quadrilateral. Now obviously the overall height and width are 14 inches, but we'll go ahead and add those. And the length of this edge, which is 16 and 7/16, will be good to know, so let's add that. The bottom is 5 and 25/64. And then finally that spring angle, which is again 31.6 degrees. All right, simple, quick, precise. Again, I'll go into detail on how to use this with the Follow Me tool to extrude and create our 3D Frustum, along with a series of refinements in the in-depth tutorial. But for a teaser sneak peek, all right, next let's build on that with something a little bit sexier, everyone's favorite workhorse, the ramp sink. Now, just like the Frustum, I like to model ramp and trough sinks as extrusions as well, and I find it really helpful to start with the profile or the cross section. A few design requirements. First, I know I want it at most 5 inches deep and roughly 15 inches from front to back. For a typical 22-inch vanity counter, these dimensions work great. I also want a seamless infinity style slot drain where it's hidden from plain sight. Now, slot drains that are integral to the form can always be a little dicey, and there are some implications we need to think through. Now, modeling in SketchUp has really helped me identify and address those early in the design process, so I can be confident that I'm not doing something stupid, overlooking an undercut or something else that might cause the mold to get locked in. Now, I also want the sides of my sink to have more dramatic compound angles. Now, this can make our mold much more challenging to construct, especially if we were fabricating it directly. But the modern, aesthetically pleasing result, in my opinion, is so worth it. Now that said, I'm going to show you some tricks that are going to dramatically simplify mold fabrication. We'll get some economy of scale, and it's going to unlock tons of possibilities. Now, working in the positive first is our friend here. All right, let's get into it. Again, I'll make things easy by looking at this from the right side view, and I'm going to draw myself a helper bounding box of 15 by 5. Now, like most ramps, for this design, I want the back to be steeper than the front and the slot drain to land right about 4 inches from the back, so I'll draw a guide there. And next, I know I want my slot drain to be a 1/2 inch wide, pretty typical, so I'll draw another guide there. Now here's where things get tricky because of that integral infinity style slot drain. What I'm beginning to model here is the bottom of that integral slot. Now it does not include drainage plane. So for reuse, I found it best to scab on a rigid PVC foam board to the bottom of the channel, and that'll form that drainage plane once the final dimension and the location of the drain is determined. Now this yields the most flexibility and reuse, but hold that thought for right now. So given that, I'm now going to model the other side of the channel, the integral slot, and make sure it also has draft. Here I'll use the Protractor tool, and I'll just give myself 5 degrees. That gives me enough draft on both sides of that channel and helps ensure it's going to unmold. Now that integral channel will be roughly 3/4 of an inch deep. That's enough to keep it hidden from the naked eye where it butts up to the PVC foam board, so I'll draw another guide for that. Now I have all the guides I need. It's simply a matter of using the pencil tool to trace over and connect all of the dots, and voila! Now it may not look like much right now, but in the detailed video I'll show you how we're going to model this out in a 3D, model our sides with the compound angles, and really add some spice to it. I think you're going to like what you see, and also start to get some insight into how we will fabricate these in my fiberglass workshops. Now this approach can be a game changer and really add to your bag of tricks in mold fabrication. Okay, I have one more trick to show you, and it's kind of a hidden sort of unknown feature, and that is the ability to scale objects. Now maybe you're aware of this, but it certainly wasn't obvious to me in the beginning, and that is how SketchUp allows you to change the size and proportionally scale an object after it's been modeled. Now the good news is that there's a way to scale entities in SketchUp, and for that you use, you guessed it, the tape measure tool. In much the same way you can enter dimensions for an entity after you've drawn it, you can measure an edge of an entity and then enter a dimension. This tells SketchUp that you want to resize that entity. Now this is very powerful, and SketchUp will prompt you to make sure that this is what you want to do, because without care, this can have some very adverse effects on your overall model. Let's explore. Okay, let's just dive right in with the frustum we modeled. Here, I already have it extruded and modeled to have top dimensions of 28 by 28. You'll also notice some of the other entities in the model that demonstrate parts laid out on a 4 by 8 rectangle representing sheet material. Let's now scale that to 36 by 36. Starting with the tape measure tool, I'll simply measure this edge. Notice how it correctly indicates 28. Now, if I type in 36, notice the prompt. SketchUp's making sure I want to rescale the entire model by that factor. In this case, it's roughly 1.3. If I go ahead and confirm, notice how everything is now scaled up. Again, this may or may not be what you want. Now, in this case, it throws things off because it also scaled up my sheet material to be larger than 4 by 8. Not what I needed. Now luckily SketchUp provides a way to be more specific. We already have this grouped, but if it wasn't, we could group it and then double click and enter the group. Now like any other operation, we're performing it inside the group, somewhat isolated from anything outside. So in this case, if I now measure that edge and type in the 36, notice how the prompt is different. SketchUp's now confirming that I want to perform this on just the active component. If I confirm, notice how the frustum rescales, but the rest of the entities in the model stay the same. In my case, this is exactly what I want. Now, as you can see, scaling is really straightforward and can be really powerful. Just need to be aware of the extent of what you're scaling, whether it be the whole model or just an individual component within your model. Now in another video, we'll have some real fun, and I'll show you how I took this simple floor plan from the lease listing and was able to scale it, then use guides to accurately lay out the shell and build it out. It gave me all the dimensions I needed, and that gave me a huge jump on making some decisions, figuring out how I was going to lay the overall space out to support my desired workflow, and even order some things like the racking back there before I even had the keys. In that video, I'll show you how. Well, I hope that was helpful. It's amazing how simple tools like the tape measure, protractor, and dimensions can be so incredibly useful when applied to different tasks like I just reviewed. Again, super helpful to me, and I can only hope that these tips will be helpful in some way to you as well. Keep taking those creations to the next level, and I'll see you in the next one.